Hello, so in today's class we will look at the second area problem. So we have seen the first area problem. So in first area problem we were finding what is the area between y equal to f of x, y equal to g of x, and x equal to a and x equal to b. So you have some region of this form. Okay. So we were finding this is the curve y equal to f of x, and this is f of x, and this is g of x, then this is x equal to a and x equal to b. So we were finding the area. So that is given by integral a to b. So if this is the curve g of x and this is f of x, so you will have g of x minus f of x dx. Now same way in the second area problem, what we do is we will reverse the roles of x and y. So instead of having a curve of the form y equal to f of x and y equal to g of x, we will have curves of the form x equal to v of y and x equal to w of y, and y varies from, so y is equal to c and y equal to d. Now we need to find the area which is bounded between these two curves. So here in the second area problem you will have v of y less than or equal to w of y. So they do not cross each other. So this curve w of y will lie towards the right of the curve v of y. So they can touch at some point but they do not cross. Now we need to find the area bounded by this region between the lines y equal to c and y equal to d. So by the area problem, so similar to the first area problem, so here it will be given by, അപ്പോൾ നമ്മൾ rectangles എടുക്കുമ്പോൾ നമ്മൾ ഇങ്ങനത്തെ rectangles എടുക്കുക. So you reverse the roles of x and y. So what we are going to get is integral c to d w of y minus v of y dy. So that is the second area problem. Okay. അപ്പം നമ്മൾ സെക്കൻഡ് ഏരിയ പ്രോബ്ലം യൂസ് ചെയ്യുന്നത് ചിലപ്പോൾ നമുക്ക് റീജിയൻ ബൗണ്ടഡ് ബൈ കർവ്സ് ആയിരിക്കും തരുന്നത്. അതെപ്പോഴും ഫസ്റ്റ് കേസിൽ ചെയ്യുന്നതിനേക്കാളും ചിലപ്പോൾ എളുപ്പം സെക്കൻഡ് ഏരിയ പ്രോബ്ലത്തിന്റെ ഫോമിൽ ചെയ്യുന്നതായിരിക്കും. So in those cases we'll use function in terms of y instead of x. So let us write the problem. So if w and b are continuous functions and if w of y is greater than or equal to v of y for all y in closed interval c to d, then the area of the region bounded on the left by x equal to v of y and on the right by x equal to w of y so below by y equal to c and above by y equal to d is, so the area will be integral c to, so that is integral c to d w of y minus v of y dy. So that is the required area. So let us see a few problems using this. So the first question is find the area of the region enclosed by x equal to y square and y equal to x minus 2 integrating with respect to y. integrating with respect to y. So the graph will be, so this is y square equal to x. Now y equal to x minus 2. So it will pass through the point when x is 0. Y value will be minus 2. And when y is 0, x will be equal to 2. So it will be passing through the, touching the points. So it will be passing through the points 0, minus 2 and 2, 0. So this is the line y equal to x minus 2 and this is x equal to y square. So on the right side you have y equal to x minus 2 and on the left side you have x equal to y square. Now let us look at what are these points. So the points of intersection of the curves are given by, so let us form the equation in terms of y. So you have y square equal to x, up x in the value y plus 2 varum. So that implies y square minus y minus 2 equal to 0. So you will have y minus 2 into y plus 1 equal to 0. So y will be 2 and minus 1. So this will be when y is equal to 2, x will be equal to 2 plus y. So when y is x in the value 4 varum, so this will be 4 2 and this will be when y is minus 1, x will be equal to 1. So here the region is bounded by y equal to minus 1 and y equal to 2. So let us now find the area. So therefore area will be equal to integral. So you will have integral minus 1 to 2. So x is 2 plus y. So on the right side you have 2 plus y. So that is 2 plus y minus y square dy. So upon integrating you will get 2y plus y square by 2 minus y cube by 3 from minus 1 to 2. So that will be 2 into 2 minus and y യുടെ രണ്ട് ലിമിറ്റ്സ് എടുക്കുകയാണ്, അപ്പോൾ 3 വരും plus 1 by 2 into y square ലിമിറ്റ്സ് 4 minus 1 വരും minus 1 by 3 into y cube ന്റെ 8 minus minus 1. So that will be 6 plus 3 by 2 minus, okay, 1 by 3 into 9. So that is again 3. So that is 9 plus okay, 3 by 2. So that is 3 plus 3 by 2. So that will be equal to 9 by 2. So the required area is equal to 9 by 2. Next problem is sketch the region enclosed by the curves and find its area. So you have x equal to sin y and x equal to 0, then y equal to pi by 4 and y equal to 3 pi by. So this is the given region. You have the graph of x equal to sin y, then x equal to 0 is the y-axis. So this is x equal to 0, x equal to sin y. So here you have y equal to 3 pi by 4 and here you have y equal to pi by 4. So on the left you have x equal to 0 and on the right you have x equal to sin y. So therefore the area is given by integral pi by 4 to 3 pi by 4 sin y minus 0 dy. So the integral will be minus cos y from pi by 4 to 3 pi by 4. So that is minus. So cos pi by 4 is minus 1 by root 2 minus 1 by root 2. So that will be 2 by root 2. So the area is going to be equal to root 2. So the region is bounded by the curves y equal to x square. Then you have y equal to 9. Then we need to find a horizontal line y equal to k such that the area from above y and below y equal to k, both are the same. So this will be the curve. So you have y equal to x square. So y equal to x square implies, so you'll have x equal to plus or minus root y. So this will be x equal to minus root y, and this will be x equal to plus root y. So let us take the region 1 and region 2. So area of 1 must be equal to area of 2. So when you look at area of 1, so you have curves on the right and left side. Then it is bounded below by y equal to 0, above by y equal to k. So the area of first region will be integral 0 to k root y minus root y dy. So that will be equal to integral k to 9. So you will have again root y minus root y dy. So that will be equal to so integral 0 to k 2 root y dy is equal to integral k to 9 again 2 root y dy. So that means okay, when you integrate you will get 2y raised to 3 by 2 by 3 by 2 from 0 to k. Then again 2y raised to 3 by 2 by 3 by 2 from 9 to k. So 4 by 3 will cancel off on both sides. So you will get on the left side you will get k raised to 3 by 2, that will be equal to again k raised to 3 by 2. Sorry, this is, it is 9 here and k here. So 9 raised to 3 by 2 minus k raised to 3 by 2. So 9 raised to 3 by 2 minus k raised to 3 by 2. So 2 k raised to 3 by 2 will be equal to 9 raised to 3 by 2. So that will be equal to 27. So k raised to 3 by 2 will be equal to 27 by 2. So k is going to be equal to 27 by 2 whole power 2 by 3.